everyone, welcome to my channel Do and Learn. This is part 2 of the chapter Motion in a Straight Line based on NCERT Syllabus from the grade 11 Physics. The contents are motion graphs, significance of motion graph, what are the uses of motion graphs, and kinematics equation. We are deriving kinematics equation for uniformly accelerated motion by graphical method. Remember, if you learn the uses of motion graph, you can easily derive the kinematics equation. So the uses of motion graphs are the basic. So I will start from the graph first, then I will go to the kinematics equation. So if you learn the graph and its significances, it is very easy to derive the kinematics equations. So let us start from the motion graphs. So if a body moves in a straight line path, its motion in one dimension and is called linear or rectilinear motion. I have discussed this in the previous video, the part 1. If you did not watch the previous video, the link is given in the description. You can click the link. The part 1, I have explained what are one-dimensional motion. Let us continue. There are mainly 3 types of graph. Motion graphs: displacement time graph, velocity time graph, acceleration time graph. Let us study what is displacement time graph. The slope of the displacement time graph gives a velocity. For a body moving with uniform velocity, the displacement is directly proportional to the time. Let us see what are the graphs. You can see the first graph. The curve is parallel to the x-axis. So the object position at 40 meter at 0 time, initial time 0 time, the object is at 40. At 10 second, object is remain at 40. At 20 second, object again remains 40 meter. At 60 second also, object is at 40. It means object is not moving. The first graph shows the position time graph of a stationary object. Look at the second graph. The curve, look at the picture, the curve is like this and the object is in uniform motion, we can say, because when the time increases, object is covering some distance. Again, time increases, object is covering some distance. So if you find it, object is covering equal distance in equal interval of time. So that is called a uniform motion. Object is moving with the uniform velocity. If you calculate the velocity at any point, it will be same. Let us learn how to find the velocity from displacement time graph. You can see the displacement time graph. The time is along x-axis and the displacement is along y-axis. We know that the slope of the displacement time graph gives the velocity. What is slope? What is slope? Slope means we can say vertical change along y-axis divided by change along x-axis. We can say delta y divided by delta x. Look at this picture. If you are considering 2 points, the point A and B, so you can calculate or you can measure the change along y-axis. This is a y-axis. Starting point is 20 and final point is 40. The change between 40 and 20, that is the distance BC, right? So we can say that is BC divided by along x-axis. We have the point A and C here. This means 4 and 2. 4 we can write BC divided by AC. Put the values. BC means 40 minus 20. 40 minus 20 divided by 4 minus 2. 4 minus 2. That is equal to 40 minus 20. 20 divided by 4 minus 2. 2. Equal to 10. Right? 10. So 10 is this is the value of velocity. What is the unit of velocity? Meter per second or meter second inverse. 10 meter per second. This is the velocity of this motion. So this is the way we calculate velocity from displacement time graph. Very easy. The slope of the displacement time graph gives the velocity. Let us study what is velocity time graph and its significance. As you can see, this is velocity time graph for uniform velocity. So the velocity is along y-axis and the time is along x-axis. At 10 seconds, the velocity is 20. At 30 seconds is also 20. At 60 seconds, the velocity is 20 meter per second. So the velocity is uniform. If the velocity time graph, the curve is parallel to the x-axis, we can say the object is moving with the uniform velocity. From the velocity time graph, we can calculate the distance, displacement, and the acceleration of the body. Let us see how to calculate distance, displacement, and acceleration from velocity time graph. The area enclosed between the velocity time sketch and x-axis gives the displacement of the body. So area enclosed above the time axis represents the positive displacement, that is the distance traveled away from the starting point, while the area enclosed below the time axis represents the negative displacement, that is the distance traveled towards the starting point. The total displacement is obtained by adding them numerically with proper sign, but the total distance traveled by the body is their arithmetic sum. So from this graph, let us see how to calculate the total distance or displacement. You can see there are three types of structures. There are three structures: triangle ABC here, and trapezium CDEF, and trapezium FGHI. So the displacement in this region will be positive, this will be negative, this will be positive. Let us see how to calculate. As I told you, the area enclosed between the velocity time sketch and x-axis. That means the area of triangle ABC plus the area of trapezium CDEF plus the area of trapezium FGHI will give you the total distance and displacement. So area of triangle ABC plus area of trapezium CDEF plus area of trapezium FGHI. We have the formula to calculate the area of triangle, that is half base into height, and area of trapezium half sum of parallel sides multiply height. Let us calculate. Consider the triangle ABC. The area is equal to half base into height, that is equal to half. What is the base? 0, 1, 2, 3, 4 till 4. Therefore 4 multiply height. Height is how much? 5. 4 multiply 5. Therefore 4 multiply 5, 20 divided by 2 equal to 10 meter. The object travel 10 meter along the curve AB and BC. Next, consider the area of trapezium CDEF. CDEF. That is equal to, as I told you the formula, half multiply sum of parallel sides. What are the parallel sides? DE and CF are parallel sides. So CF plus DE multiply the height. Put the values. CF is how much? 9 minus 4. 9 minus 4, that is 5. 5 plus, what is the value of DE? That is 8 minus 5. 8 minus 5, 3. 5 plus 3. Multiply height. What is the height? So it is given here. The height you can calculate straight to the y-axis. That is 5. Equal to 5 plus 3, 8. 8 into 5 divided by 2 equal to 40 divided by 2, 20 meter. Along the along the curve CDEF, the distance or displacement is equal to 20 meter. Again, we have one more structure. Let us calculate the area of trapezium. Area of trapezium FGHI equal to half multiply sum of parallel sides. We have parallel sides GH and FI. That is 13 minus 9. 13 minus 10, how much? 4. Plus GH. GH is 10 minus 12 minus 10. That's 4 plus 2. Multiply the height is same, 5. Equal to 4 plus 2, 6. Multiply 5. 30 divided by 2 equal to 15 meter. That is the displacement along the curve FGHI, 15 meter. So total is equal to, we have to find the sum of the area enclosed by the triangle ABC, trapezium CDEF and trapezium FGHI. So first we have got already 10. Second, we know that it is below the time axis, so it should be negative. Put the symbol negative displacement, so minus 20. Then the area below the curve FGHI is positive, that we have calculated just now, that is 15 positive displacement. So that is equal to 15. So 10 minus 20 plus 15, how much? 10 minus 20, you can calculate what is 10 minus 20 plus 15, that is equal to 5 meter. 5 meter is the total displacement. So let us calculate what is the total distance. Total distance, same, you have to find the sum of the area of the triangle ABC, trapezium CDEF, trapezium FGHI without any sign. So 10 plus 20 plus 15, how much? 10 plus 20 plus 15, 45 meter. So the displacement is 5 meter, distance is 45 meter. This is the way of calculation of displacement and distance from velocity time graph. Now let us see how to calculate acceleration from velocity time graph. The slope is equal to acceleration. Slope will be equal to acceleration. The slope of velocity time graph will give you the acceleration. Let us calculate acceleration along the curve AB now. As an example, the slope is equal to, as I told you before, delta y divided by delta x. Here, this is the curve A and B. So, delta y will be the distance between the point B and the x-axis. How much? That is equal to 5 divided by distance between the point A to this point. That is 3. 5 divided by 3. How much 5 divided by 3? 1.67. So unit of acceleration is meter divided by second square. This is the way of calculating acceleration. Let us see what is acceleration time graph. In acceleration time graph, time is along x-axis and acceleration is along y-axis. This graph shows acceleration time graph with the uniform velocity. If an object moving with the uniform velocity, the acceleration will be 0. So you can see the acceleration 0, time increases, acceleration still 0 only. So the graph is along x-axis, and this is the acceleration, the constant acceleration. The object is moving with the constant acceleration, uniform acceleration. So the curve will be parallel to the time axis, x-axis. And another one, this graph represents the retardation, uniform retardation. You can see the graph is in the negative region of the graph. From the area enclosed between the acceleration time sketch and the time axis, we can find the velocity of the body. So if we can measure the area here, this area, this will give you the velocity, same as we get displacement from velocity time graph. So from this we have studied velocity time graph. From velocity time graph, we can calculate displacement, distance and acceleration. And acceleration time graph, we can calculate velocity. And displacement time graph, we can calculate velocity. Let us see how to derive kinematics equation for uniformly acceleration motion from the motion graphs. These are the kinematics equation. V is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as, where u is equal to initial velocity, v is the final velocity, a is the acceleration, t is the time, s is equal to the displacement. So we are going to derive the equation v is equal to u plus at, and second equation s is equal to ut plus half at square, and the third equation v square is equal to u square plus 2as from a velocity time graph. You can see a velocity time graph here with the uniform acceleration. Let us start. So we know that acceleration is equal to slope of the velocity time graph, slope of the curve of velocity time graph. Here we have the slope is AB from the graph. This is the curve AB. The slope is equal to this distance, right? Delta y divided by this distance, delta x. So it is equal to BE divided by AE. What is BE? BE means this much distance. That will be equal to total distance. This total distance is D to B minus E to D, right? So BE is equal to BD minus ED. So AE same as OD, right? So OD equal to, what is BD? BD same as V. BD is equal to V. What is ED? ED is equal to O. So this much distance is called U, right? So ED is equal to OA, that is equal to U. V minus U. What is OD? OD is a distance from origin to the T. So that is equal to T. V minus U divided by T. So acceleration is equal to V minus U divided by T from the graph. So we can write AT, we'll send the AT to the left side. AT is equal to V minus U. Therefore, V is equal to U plus AT. We are sending A to the left side, V to the left side, and AT to the right side. We get V is equal to U plus AT. This is the first equation. V is equal to U plus AT. We have derived the first equation by finding the slope of velocity time graph. Next, we are going to derive the second equation, second kinematics equation. So to find it, we have already told displacement or the distance is equal to area under the curve of velocity time graph. Area under the curve of the curve AB. Area under the curve AB. So we know we have area, we have the curve AB. Area under the curve will be, there will be a triangle BEA and another rectangle OAED. So that is equal to rectangle area of rectangle OAED plus area of triangle ABE. So let us calculate. We have the formula to find the area of rectangle, that is length into breadth. length is equal to AE multiply breadth how much, or the height how much, ED plus area of triangle area half BH, right? Half into base into height. Base is how much, AE, height how much, EB or BE, BE. So that is equal to AE. AE means is equal to time T multiply ED. E to D is equal to U from the graph. So U into T or T into U plus half. What is AE? AE is same as T time T multiply. What is BE from the graph? BE already we have shown you the previous one. BE is equal to V minus U. V minus U. So that is equal to UT plus, what is V minus U? What is V minus U? The previously we have shown V minus U is equal to AT. We will use this here. We have V minus U is equal to AT. So 1 by 2 multiply T multiply AT. So that is equal to UT plus half AT square. So that is a distance. So we have got the second kinematics equation derived now. S is equal to UT plus half H square. So now we can derive the third equation. Use the same method. We have the distance S is equal to, let us consider this as trapezium. O, A, B, D. Consider S is equal to, the distance is equal to area of trapezium O, A, B, D. Previously we have considered this as one triangle and one rectangle. In this case we will consider this as a trapezium. So we have the formula to find the area of trapezium, half into sum of parallel sides. The previous example I have already showed you, sum of parallel sides. Sum of parallel sides multiply the height. So here sum of parallel sides are, what are the sum of parallel sides? The parallel sides are BD and AO. So half multiply sum of parallel sides means BD plus parallel side. Another parallel side is OA. Multiply the height. What is the height here? Height is equal to, this is a height, right? This height is equal to OD. That is equal to 1 by 2, put the values, half multiply BD how much? BD is equal to V plus OA is equal to U from the graph, V plus U multiply OD is equal to T. So we have half multiply V plus U multiply T. So now put the value of T in this equation. We have T is equal to, so previously from this graph, from this equation, you have to get the value of T. We have T is equal to, from this equation, T is equal to V minus U divided by A. Okay, apply this in this equation. T is equal to V minus U divided by A. Put these values here. That is equal to 1 by 2 multiply V plus U multiply V minus U divided by A. So now we have half V plus U multiply V minus U divided by A. So now we have, I will write this equation again here, half multiply V plus U multiply V minus U divided by A. So we have, this is a displacement. S is equal to half V plus U multiply V minus U divided by A. V plus U into V minus U. v plus u into v minus u, same as a plus b into a minus b. We will get v square minus u square, same as, because or since a plus b multiply a minus b equal to a square minus b square. Apply here, we will get half a is already there, 1 by 2 a v square minus u square, v square minus u square divided by 2a, that is equal to v square minus u square divided by 2a. So again put the values here, send the 2a to the left side, we get 2as is equal to v square minus u square, 2a is equal to v square minus u square. Therefore v square is equal to u square plus 2as. We will send the u square to the left side, we will get it, v square is equal to u square plus 2as. This is the third equation. Okay, I'll explain once again in briefly. First we will find the acceleration. Acceleration is equal to slope of the curve AB. So acceleration we have BD minus ED divided by OD, V minus U divided by T. Therefore we will get the first equation, V is equal to U plus AT. And second we will find the area of the curve AB, area under the curve AB, that is equal to, this is two structures, one triangle here and one rectangle. Area of rectangle OAED plus area of triangle OBE, that is base into height, here half BH. So we will get T into U plus half T into V minus U. Okay, so we will get UT plus half AT square. Then we have the third, to get the third equation, we will use the same thing, area under the curve AB we will consider as a single structure, area of a trapezium OABD, that is equal to half into sum of parallel sides into height, it will be V plus U into T. Put the value of T, we have T is equal to V minus U divided by A, so it will be half V plus U in multiply V minus U divided by A. Then V plus U and V minus U we have V square minus U square. Put the value, we will get half V square minus U square divided by A. Therefore this is equal to V square minus U square divided by 2A. So send the 2A to the left side, 2A is equal to V square minus U square. Therefore V square is equal to U square plus 2A. Yes, and we have derived all these three equations. V is equal to U plus AT, this is equal to UT plus half AT square, V square is equal to U square plus 2AS. So from this session we have discussed what are the uses of motion graphs and how to derive kinematics equation for uniformly accelerated motion by graphical method. So in the previous section I already explained you what is motion, displacement, velocity, acceleration, everything. The part 1, if you haven't watched the part 1, the link will be given in the description, you can watch. The next part will explain what is relative velocity and numerical problems and solutions. If you find this channel and the video is useful, please subscribe and share. Thanks for watching.